Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Before I introduce today's guest, let me tell you a little bit more about this podcast for those of you who are new to it. Data Unchained has been covering the topics around how decentralized data has come about, and also how can you put it to work to solve some of the biggest problems and opportunities in your business. So thinking back to the days where most data was created in a mainframe and the humans, the machines, everything was sitting local to that data, to a very distributed world where data now is created in servers, at the edge, on devices, in the cloud. You know, the list goes on and on. How do we capture that data, bring value to it, and help you and your business to move faster? Today's guest, Hao Zhong, is the CEO and co-founder of ScaleFlux. Hao, thank you for joining the show today.
Thank you for having me.
So before we talk about ScaleFlux and the SSD market, which is something you are smack dab in the middle of, tell us a little bit about your background.
So I came to US about 23 years ago for my PhD study at RPI. The topic we started was very interesting. It's actually to make the chips to help the hard disk drive to store more data with higher density and capacity. We have to convert an advanced error correction algorithm into the chips that can help read and write data in more dense area in the magnetic recording. And coincidentally, this research actually got picked up by a company called Agia, later merged into LSI and Broadcom. And we were able to commercialize my PhD research into the product that goes to massive market of hard disk drives and help drive the density of HDD to, from hundreds of gigabytes to now tens of terabytes. And then, as we know, you can drive the density and the capacity of hard disk drive, but there's nothing we can do to further improve the speed of a hard disk drive because the spindles. And then I joined a startup in the Silicon Valley called Sanfors to take this challenge to bring the high-speed storage device called SSD. Now, everyone knows SSD, but by that time, actually, very few people even believed it. And it became, one of the game changer for the data storage industry. And the first one that massively adopted that was actually, if you remember the MacBook Air. That's the one that really used the advantage of the fast and low power and low latency of SSDs to replace hard disk drives.
I think that them being drop proof was important too. I remember thinking the commercials of MacBook Air, you can drop it and it will still work even if it's powered on. That's
right. So we are really proud that we were part of that innovation. And then it comes to data center. Sanfors made that happen and got acquired by LSI. And another very interesting company called Fusion.io took this idea to data centers for the servers. And they get rid of the slow interface that at that time was a SATA and SAS for the disk drives. They directly use PCIe for the fresh memory, and that became later on the PCIe and NVMe SSD. That was another great journey to help the industry really revolutionize the traditional from the hardware all the way to the software. That what you see. I'm sure that there's amazing companies out there to keep pushing the envelope, and will be part of that as well.
So that's a great lead into ScaleFlux is the company which you co-founded and are CEO of. tell us a little bit about ScaleFlux. Of course, it's in the SSD space, but I would think it would be great to introduce your company here for a moment.
Yeah, sure. As you know, after being through the HDD, the laptop SSD, and the data center SSDs, at that time we were thinking, what's the next? How can we keep driving the technology forward? That's why when we founded the ScaleFlux, we picked a topic called the acceleration, which means, in the future, acceleration need to happen everywhere because the Moore's law has certain limit, right? And we cannot rely on the CPU to process anything, all the workload, right? So that's why, I think we got the right trend. And however, what we didn't predict well was, the acceleration happened way bigger at the GPU and the TPUs. That's why you see, the tremendous progress over there, and then propagate to the network, the DPU, smart NIC, right? And now I'm sure that something will happen at the data storage, and we are in the best position to help this.
You did a great lead-in on some of the evolution of the industry, of why SSDs were needed and then how they got moved into the data center. How would you continue that thinking, looking at what's happening in AI data centers? What is the demand? How is it different, perhaps, than some of the traditional, maybe enterprise or cloud data centers?
That's a great question. So when we started, there's no AI demand at that time. And what all we want to do is how can we make the data storage more efficient, right? And if we look back, we literally made the most advanced SD controller chip solutions for the market, doing the acceleration, transparent compression, data filtering, right? And this helped us to eventually get into some key customers to help them significantly reduce the cost and improve the efficiency. And then the AI, infra demand happened, and they are also looking for more efficient storage. Especially, we are seeing the demand on the high performance for the near GPU processing, and also for the high capacity, high density for the data store. So that's why with the AI, there's more demand on the storage for different applications. Either it's a near GPU compute, or it's a high density, high capacity main storage.
And can you break down for us? I personally get to see quite a few SSD roadmaps, and there's a lot of types of SSDs. Can you maybe just break down what is the latest? Who are you designing it for? When you think about some of these trends on the storage side?
Mm-hmm. Yeah, so as a chip solution provider, we mainly work with customers such as the hyperscalers and storage system companies that being part of NVIDIA and AMD and the hyperscaler ecosystem, and also directly with memory companies that help them build more advanced SSDs. So those are the major categories of the customers that we have been working with.
And are you developing different SSD technology for AI because of the workloads? Is it the environmentals of, you need to run in a hot data center? How are you thinking about the next generation of SSDs related to AI?
This is a fantastic question. So as you know, in the past, all the SSDs have been designed for the CPUs. However, as you know, the PCIe generation evolved on average 4 or 5 years per generation. Of course, now getting a little faster. And every generation, there's a performance only double. So that is hard to keep up with the GPU and the TPU speed growth, right? So then NVIDIA took the initiative, hey, can we change the paradigm? How can I have the next generation SSD with 10 times more performance instead of 2, right? And this is a big challenge for the whole industry. However, we love those type of challenges, and because we have designed the most advanced controller chip solution for the industry, naturally we become a leading partner for the industry, for the ecosystem to make that happen. So we're on that. The other thing that we talked about, the content growth, right? So you need more capacity, more density to store the data. That's why you are seeing the large capacity SSDs with QLCs, right? The normal HD is only like 16, 32 terabytes. And now you are seeing 128, even 256 terabyte of SSDs came to the market. And, they are in much smaller form factor and much lower power and much faster. So that's truly amazing how the SD technology has evolved for so long.
And do you find that it's just about the chip or what's designed into the SSD that matters? I know you're part of the Open Flash platform where it's kind of a system level design. How do you think about your design requirements and what needs to be done at the system level or the DPU level or the chip level? Kind of how do you think about that as you design your roadmap?
Yeah, when we look at that we need to look at from the user experience point of view. After all, the solution is going to serve for the application for the customers. Right? So that's why we have to look at the whole picture instead of just a component itself. SSDs, the control chips is going to plug into SSDs. SSD is going to plug into the servers. Server has the system, software running on top of that, and the server for the applications, right? So we need to look at the holistic picture. And when we design the controller chip and the firmware, we need to think, how can we help our system partners like Hyperspace and others, customers, to figure out what's the most efficient way to manage the flash memory, how to maximize the utilization, reduce the overhead, improve the overall latency, and improve, very importantly, is the reliability of the system. Right. So that's why the Open Flash platform has a unique advantages to look the whole system as a complete design instead of just design your SD and then let the system and the partners figure out how to use it.
If I'm not mistaken, there's essentially a system on the chip where you can actually run Linux inside the SSD as part of the Open Flash platform initiatives. Am I understanding that right?
One of the core features that eventually will emerge in the market. Think about the SSD controller itself. It's just like a little processor in the SSD. Of course, in the past, it only do manage the read and write to the flash memory and doing the background garbage collection and managing those meters, right? However, if we take one step further, since it's already running, ARM and has a little file system inside it, right? What's wrong to make it more powerful and balance the future platform, between the storage network and compute to make it more efficient, more well-balanced system, right? So that's why the Open Flash platform enables the possibility to solve the system issue in more flexible way and also more innovative way to look at that.
It's been fun watching yourself, David Flynn, some of the leaders who had that vision early on for moving SSD, into the servers, into the data center, and now it's proliferated. It's in all of our iPhones. It's in all the cloud data centers, and now I feel like we're kind of have a front row seat to the next generation as we look at this idea of running the controller within the SSD in this little tiny device. It's just amazing to me I can't even fathom that you would have envisioned this 10, 20 years ago, as you were going through your
Right.
PhD program. But the capabilities in such a small device are staggering as far as how they help the workflows too.
Yes, absolutely. So that got us very excited, especially if you really think about that. The whole server in the past with HDDs, they can only store probably up to 100, 200 terabytes, right? Today, just one, small form factor SSD, they can store 256 or even 512, and soon will be 1 petabytes, right?
Mm-hmm.
So it's like that a single small SSD can store, half petabytes or even petabyte, then essentially it's just like a storage server. And the processor or the controller chip in that SSD is just like a CPU in the traditional storage server. If you look at that way, right? So it's like you are compacting. So evidence, okay, like you have a mainframe computer, now you have a laptop, which is even more powerful, right? So this is happening actually in the SSD and data storage server domain as well.
And it's fun. I go to quite a few technical conferences, which I'm sure you do as well. And as you present this concept, looking at some of the engineers and architects, understanding the impact of that, like, wait a minute, I'm running my server in my SSD and the ramifications of that and their workflows. It's all of a sudden you see their eyes light up and they nudge their neighbor and say, wait a minute. And you can see them whispering about it. It's really exciting to see.
Mm-hmm.
And in this light, while we're all excited about the capabilities, we're also dealing with an SSD shortage, or one that, is in the news, probably going to affect us at least for another year. Maybe we can talk about that a little bit. That, previously the idea of putting a petabyte of data and needing that much storage wasn't really that necessary, but the speed that data is being created is accelerated massively, largely due to AI, but sensors and robotics and other things too. What has led to the SSD shortage that's, pretty heavily in the news right now?
Yeah, I think there are many reasons, and one of the major reasons is, with the huge success of NVIDIA, people notice that it's really important to put more investment in the compute. Right? As you see, a lot of the GPU, TPU, AI accelerators, they receive huge funding to, keep pushing the envelope. And now, in the past, there's one processor company having like over 90% of data center business. Right now, you are seeing maybe at least dozens of AI processors in the market, right? And on the other hand, how many of the new memory companies, have you seen in the market?
I'm not sure if there's been any. Have there?
That's right. So, and not only that, because of the, most of the funding went to the compute, some of them even reduced their capacity, right? Because there's a really severe down cycle for the memory and storage industry in 23. And that was really tough for, storage guys and memory guys. So on the other hand, there's such a booming market for the GPU and the TPU. And now, at the end of the day, you need to build more servers with proportionally with more SSDs and hard disk drives, right? And meanwhile, the Gen AI is producing more data, more contents, and the growth speed of the storage is actually probably is exceeding the demand on the processing. So if you look at the history, what happened and what's happening today, that will we see tremendous gap, and that will probably press the industry to really think about how can we keep up with that. So as you know, the foundry, the supply chain building up is not a very fast thing. It will take some time.
Absolutely. And from a ScaleFlux perspective, whatever you can share, how do you feel you'll be able to help your customers in the industry through this next kind of difficult year or so?
I think efficiency is very critical. So because of the shortage, then people need to really look into how can I most efficiently use the capacity of SSDs. So we are the leading provider of computational storage with transparent compression, which our customers can expand the capacity multiple times, from 4 terabyte to 10 or even 16 terabyte usage. So that significantly help our customers to improve the efficiency of the storage and lower the cost, especially in today's market. Right. The other thing is keep the innovation on driving the performance, because some application like GPU, right, the performance per gigabyte sometimes is even more important. Otherwise, you need to put a lot of SSDs to
over provision, right? Yes.
Right. So those are what we can do to help our ecosystem partners to navigate the challenge of the shortage.
And how, as people are thinking through learning more about the ScaleFlux technology, what is the best way to learn about your technologies? Is it going to your website? Do you have conferences that you're attending right now that you would point people to?
Yeah, sure. So there's 3 major events we'll be in. The GTC, GTC, that is a very popular event. And then there's a Future Memory Summit, usually it's happening in August. And then there's the OCP, Open Computer Project, in October. So we'll be there for all 3 major conferences, and happy to meet, to meet with you if you are interested in this topic.
Fantastic. Yeah. Well, Hao, thank you for jumping on the show. Also, congratulations on the success so far, as you've been well positioned for a pretty market shifting opportunity as capacity is growing the way it is. And like you said, I was just thinking about while you were talking that not a lot of new memory companies have jumped in. It's not an easy market to jump into. The barrier to entry is a bit high. So I'm sure you'll have some great success in the coming years navigating through this. And we wish you the very best.
Thank you. Thank you, Molly.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.